Question 23. You are performing system testing of a train booking system and have found that occasionally the system reports that there are no available trains when you believe that there should be, based on the test cases you have run. You have provided the development manager with a summary of the defect and the version of the system you are testing. The developers recognize the urgency of the defect and are now waiting for you to provide more details so that they can fix it. Apart from the description of the defect, which includes a database dump and screenshots, which of the pieces of information would be most useful to include in the initial defect report? Given the following pieces of information. 1. Degree of impact, severity, of the defect. 2. Identification of the test item. 3. Details of the test environment. 4. Urgency, priority to fix. 5. Actual results. 6. Reference to test case specification. Question 24. Consider the following list of either product or project risks. An incorrect calculation of fees might shortchange the organization. A vendor might fail to deliver a system component on time. A defect might allow hackers to gain administrative privileges. A skills gap might occur in a new technology used in the system. A defect prioritization process might overload the development team. Which of the following statements is true? Options. Product risks affect the quality and functionality of the product. Project risks affect the project's ability to deliver on time, within budget, and with the necessary resources. So, as per the clarification, the options 1 and 3 are primarily product risks, while 2, 4 and 5 are primarily project risks. Question 25. Your favorite bicycle daily rental store has just introduced a new customer relationship management system and asked you, one of their most loyal members, to test it. The implemented features are as follows. Anyone can rent a bicycle, but members receive a 20% discount. However, if the return deadline is missed, the discount is no longer available. After 15 rentals, members get a gift. A t-shirt decision table describing the implemented features looks as follows. Check the table, based only on the feature description of the customer relationship management system, which of the above rules describes an impossible situation? T represents true. F false. X the action should occur. Blank the action should not occur. From table, rule R1 represents member true, missed deadline true, 15th rental, false, so, no discount and no t-shirt. As well, please check the other conditions. R8. Member false, missed deadline true, 15th rental true, no discount, but gets t-shirt. That is, impossible situation. Question 26. Consider the above state transition diagram of a switch. Which of the following represents an invalid state transition? A. On to off. B. Off to on. C. Fault to on. D. Fault to fault. To determine the invalid state transition, from the provided options, let us consider the following state transitions for a switch. On to off, valid transition, since switch is turned off. Off to on, valid transition, switch is turned on. Fault to on, invalid transition because switch is in a fault state, need to be reset or repaired before it can be turned on. Fault to fault, valid transition, switch remains in the fault state. Question 27. What is the expected result for each of the following test cases? A. Frequent flyer member, traveling in business class. B. Non-member, traveling in economy class. Please check the table. To find the expected results, analyze the conditions. As per Rule 1, frequent flyer member yes, traveling in business class yes, so expected outcome for test case A is upgrade to first class. Rule 2, frequent flyer member with economy class, no test case. Rule 3, non-member with business class, no test case. Rule 4, non-member with economy class, so expected outcome for test case B is no upgrade. Question 28. If the temperature falls below 18 degrees, the heating is switched on. When the temperature reaches 21 degrees, the heating is switched off. What is the minimum set of test input values to cover all valid equivalence partitions? To cover all valid equivalence partitions, we need at least one representative value from each partition. Below 18 degrees, heating is switched on. Take any value less than 18, for example, 15. Between 18 and 21 degrees, heating remains on if it was already switched on, or no change if the heating was off. Take any value between 18 and 21, example, 19. Above 21 degrees, heating should be switched off. Take any value greater than 21, example, 25. Question 29. What is the expected result for each of the following test cases? Test case A. Fred is a 32-year-old smoker resident in London. Test case B. Jean-Michel is a 70-year non-smoker resident in Paris. Expected result for test cases A and B. Option C. A. Insure, no discount, B. Don't insure. Explanation. Fred is 32 years old and a smoker. Eligible for insurance policies with higher premiums due to the health risks associated with smoking. So Fred would be offered insurance but without a discount. Jean-Michel is 70 years old and a non-smoker. Based on his age, he is ineligible for insurance coverage. So answer is, for A, insure with no discount, for B, don't insure. Question 30. The team wants to estimate the time needed for one tester to execute 4 test cases for a software component. The team has gathered the following measures of the effort used to execute a single test case. Best case scenario, 1 hour. Worst case scenario, 8 hours. Most likely scenario, 3 hours. Given that the 3-point estimation technique is being used, what is the final estimate of the time needed to execute all 4 test cases? Let us use the 3-point estimation technique. Final estimate, E, equals, A plus 4 times M plus B, divided by 6. Where A, most optimistic estimate. M, most likely estimate. B, most pessimistic estimate. Substitute the values, and the estimate for executing a single test case is 3.5 hours. So, total time needed to execute 4 test cases is equals 14 hours. Question 31. The table shows the traceability matrix from test cases to requirements. X means that a given test case covers the corresponding requirement. Please check the table. You want to prioritize the test cases following the additional coverage prioritization technique. You execute all 4 test cases. Which test case should be executed as the last one? Analysis of test cases, from the table. Test case 1 covers requirement 1, 3, 4, 7. Test case 2 covers 1, 5, 7. Test case 3 covers 5, 6. Test case 4 covers 2. Execution order. First, test case 1 covers 4 unique requirements 1, 3, 4, 7. Second, test case 3 covers 2 unique requirements 5, 6. Third, test case 4 covers 1 unique requirement 2. Last, test case 2 covers 1, 5 and 7.